Hello, welcome in. We are covering the subject thermodynamics for civil service mains, IFS, and various gate exams. And in this, we are covering the chapter first law of thermodynamics applied to flow processes. And in this, the next topic in the application of steady flow processes, throttling device. In a throttling device, the pressure is dropped, or if the pressure is dropped, then the flow is said to be throttled. Okay. So, and there is no heat supplied and no work done. So heat supplied is zero, work done is zero. Okay, and the levels are also same. Z1 is equal to Z2. So the steady flow energy equation which was H1 plus V1 square by 2 plus Z1 G plus dq by dm is equal to H2 plus V2 square by 2 Z2 G plus dwx by dm, then reduces to, because Z1 is equal to Z2, and this heat supplied is 0, work done is 0, so it will be H1 plus V1 square by 2 is equal to H2 plus V2 square by 2. So this is the energy here, and this is the energy here. If velocity at 1 and 2 is same, this is your throttling device, and it is insulated finish, no heat is supplied, and it doesn't do any work. So dw by dm is 0, this is 0, and level is same, so z1 is equal to z2, and if we assume that velocity at 1 and velocity at 2 is same, then h1 will be equal to h2. So this is the basic fundamental throttling device. H1 is u1 plus p1 v1, okay, and h2 is u2 plus p2 v2. So from this we can find out pressure drop if we know the temperature. Okay. So here I'm just reading this out. When a fluid flows through a constricted passage like a partially opened valve, this is a partially opened valve. This is valve and it is partially opened here. An orifice or a porous plug, there is an appreciable drop in pressure and the flow is said to be throttled. Figure shows the process of throttling by a partially opened valve on a fluid flowing in an insulated pipe in the steady flow energy equation. So dq by dm is equal to 0, dw by dm is equal to 0, so no heat, no work. And the changes in P are very small, this level is same as this level, and in lower. Thus, steady flow energy equation reduces to h1 plus v1 square by 2 is equal to h2 plus v2 square by 2. Okay. So here open the pipe, velocity and throttling are so low that the kinetic term is also reduced. So this is negligible. So h1 is equal to h2, or the enthalpy of liquid before throttling is equal to enthalpy of liquid after throttling. Okay. So this is your throttling flow.